In the last tutorial, we learned about how to look at a salt compound and to find out whether the solution it makes is going to be an acidic, neutral, or basic solution. So now what we have here is a salt solution with a given concentration. And along with the question, we have the acid dissociation constant, the Ka, and we have the value, which is for the hydrocyanic acid. So how does this relate to this problem? How do we make use of these numbers to find out the pH of the solution? So let's first do a quick analysis of salt and see whether the salt will make a basic or acidic or neutral solution. Lithium cyanide. When we look at lithium cyanide, lithium is coming from LiOH, lithium hydroxide. This is a strong base. The conjugate will be a weak acid, so it will not have a reaction with the water. Cyanide ion, where does it come from? It is coming from hydrocyanic acid, HCN. It is not one of the strong acids that we memorize. So this is a weak acid. And therefore, the conjugate will be a strong base. And by this quick analysis, we are able to determine which of these two ions would have a reaction with water. It will be the cyanide ion. So let's erase this. And the reaction that we're going to write is this. Some of you may ask, why don't you include the lithium in the reaction? Well, since we knew that the lithium is not going to have any reaction with the water, so it's going to be just a spectator ion. It will appear on both sides of the equation. So for simplicity, we're going to ignore the lithium ion and we just focus on the cyanide ion. Now, as I said in the last tutorial, yes, this is a strong base, but it's not as strong as the strong base that we knew. So the arrow that we put in here is going to be a double arrow. It is going to be going back and forth so that it will reach an equilibrium stage at the very end. So since this is an equilibrium reaction, so we are going to have to make an ice table to see what is the concentration at the very end when the concentrations will become constant. So at the very beginning, we have 1.25 molar of the cyanide ion. The number is the same as the ion of this concentration of the solution because the ratio between the cyanide ion and the ratio of the compound is 1 to 1. If it is 1 to 2, then you have to make appropriate adjustments. Water is a liquid. We cannot express a liquid in a concentration, so we ignore that one. Before it reacts with water, we have none of these two products. Okay. If there are some of these two products, the question would have to state that. Since the question did not state the concentration of these two substances, we would say there's nothing in the very beginning. Now, we have some change here because it will have to achieve equilibrium. What's the change? Well, we do not know. And that's why we have to put an X value right here, because we do not know how much is going to react with water and to make these ions. Since this is minus X, this will be plus X and plus X. Okay? So what is the concentration at the equilibrium? It will be 1.25 minus X the concentration of the hydrocyanic acid and the hydroxide ion would be X molar, respectively. Okay? Now, we have the equilibrium concentration with the unknown. In order to find the pH, now you should realize that we don't have the hydrogen ion or hydronium ion to find out the pH directly. We have hydroxide ion here. So what we need to do is to find the pOH, and then we find the pH. So in order to find pOH, well, we need to find out what is the number here. We need to find out what the X is. So in order to find out the X value, we need an equilibrium constant so that we can solve for X. But the equilibrium constant given right here, it is the acid dissociation constant for hydrocyanic acid. It is not for this cyanide ion. How do we find out the equilibrium constant for the cyanide ion? So if you pay attention in class, we have go over this equation and we explain why is this. So if you put the Ka here and Kw is 1.0 times 10 to the negative 14, if you put those two numbers into the equation, you will find out that the Kv is equal to 2.04 times 10 to the negative 5. That will be the Kb for the cyanide ion.